Yeah, so I'm James Harton, and apparently I can't work Keynote, but despite that, I'm a principal consultant at Alembic, as Josh said. I work there basically trying to help our team go faster if at all possible. And I've been making software for a very long time, way too long to talk about. So security and privacy are mission critical, but unfortunately, no one wants to write authentication, and especially they don't want to do it for the second and third and fourth time. And if you've written enough web applications, you know what I'm talking about. You've experienced this. So some of the motivations for us to write Ash Authentication was that, as we said, security is important and no one wants to write it, but also the prevailing tool in our ecosystem is Phoenix GenAuth. And Phoenix GenAuth generates a bunch of code for you, and then people are then going away and trying to convert that to work with Ash resources and actions. And there's just a bunch of friction there, because it's, although you can do it, it's like you've now got some generated code, you've got some code you've converted to work with Ash, and you're very far, or you've drifted a long way from Phoenix GenAuth. Code that's generated the way that Phoenix GenAuth does it means that you're essentially like inheriting an instant liability. You've got code that is now in your repo that you own, but you didn't write. And if it changes, like for example, if the Phoenix GenAuth folks go, oh shit, we've had a security problem in our code, we need to ship an update, they can't just package up a new version and publish it to Hex. All those people have to go and take that and maybe run a generator again, maybe go over the diffs and figure out what's changed. And so the combination of Phoenix GenAuth and Ash was particularly problematic because it's like the worst possible combination of those two problems. The other problem with authentication is that teams almost always underestimate how expensive it is to write an authentication system and how long it takes. And the inverse of that is customers just expect it to work and to be there, and they don't really expect to have to pay for you to write an authentication system. So every site needs it, but you don't get points for making it. It's just, as Josh said, table stakes, which means that security is a cost center. So authentication is hard to get right, but actually what I mean by that is it's really easy to get it wrong. This is a list of flaws that I just came up with off the top of my head, probably over the course of a few minutes. I'm sure there are more, but the point is that there are really heaps of ways to mess up authentication, like so many ways. And I might have even messed up when I wrote Ash Authentication, but the difference is that because it's a library, if I have, we can fix it, we can publish a dependency update, an update to Hex, and you can do mixeddeps.update. You might probably even get an automatic PR from Dependabot and problem solved, move on with your day. So I wrote Ash Authentication so that you don't have to. And it took 6 months. The first commit was over 6 months ago. It really has taken that long to do it. And to be fair, it's much more flexible and customizable and configurable than what you would build for your own app. So you're unlikely to spend 6 months building authentication, but you will spend a lot of time, probably weeks, over the lifetime of your application. So Ash. So Josh has already gone over a bunch of the stuff about Ash, but what I want to talk about are consistent and extensible. Consistency is important for security because we're not making special snowflakes. We want sensible defaults and guardrails, but also the freedom to go off the golden path if we want to, and extensible. Part of the Ash ecosystem is incredible DSL tooling called Spark that allows you to define, extend, transform, verify DSLs at compile time. It even lets you generate code if you're a weirdo like me. So regards Spark, because it is an important part of how Ash works, I've tried to think of a good screenshot that would show what it is, but really, I think the most exciting part is that I define my resources and my other parts of Ash using a DSL, and it's type checked. Well, it's checked with nimble options, so sort of type checked. It's you get auto completion, you get documentation in your IDE, and this happens automatically. So when you add an extension or you add a data layer, the DSL just shows up and it's usable. So Ash Authentication, where it's at the moment is that it's an Ash extension, a resource extension, which means that you take your existing resource functionality, which is like some data and some actions that you can perform on it, and we extend that by adding more DSL, and by programmatically defining actions and things as we go. It's multi-strategy, so we have, obviously password authentication is pretty common. We have auth 2 with a couple of predefined social sign-ins that help us, but more coming. Passwordless authentication, where you get sent you try to sign in and it sends you a secret token that you can then use to continue your login, and a custom strategy that lets you basically write your own, and it will work seamlessly with the rest of the system. Ships with Phoenix and live view support, and what we're calling a kind of a starter UI. So now I'm going to switch to sharing my VS Code, and we'll see how that goes. Okay, this one. Share. Desktop one. Okay. All right. We're in demo mode. So what I've built here is a working Ash and Phoenix application. It basically doesn't do anything except that it has a user resource in it. This user resource is stored in Postgres, and you can see here it's in the users table, and it uses a repo, uses the Ecto repo under the hood to access the data. The DSL defines the attributes, which are like the fields in your schema, what their types are, and some extra constraints like whether they can be nil. Also important information like if this is sensitive, probably shouldn't show it back to the user, that sort of thing. We have actions, and at the moment all I've defined is the default read action. I've also included a package called Ash Admin so that we can see it, and what I'm going to do is I'm going to grab Chromium, pop it in full screen, and I'm going to slide it in next to it, and so that we can see what it's doing. Okay, go away, doc. Okay, and we'll make that a little bigger. So this is your standard Phoenix application. I literally did mix phx new this afternoon, and this is Ash Admin. It shows us the APIs, which is kind of a synonym for context from the Phoenix world, and we only have one, the accounts API, and it contains one resource, the user resource. That user resource has one action in it, which is the default read action. When I call that action, there's no data in the database. So to add authentication, we're going to pop over to our mix dependencies. I'm going to copy and paste this stuff because I need to go faster. So I'm just going to paste this in, save it, and go mix deps get. Got a bunch of code in here. So we've got two packages here, Ash Authentication, which provides the core features for authenticating resources. Oh, there should be a space there. And Ash Authentication Phoenix, which provides extra features for working with Phoenix, because Ash Authentication by default just provides a bunch of plugs and a plug router and a few things like that. So you don't actually have to use Phoenix to use authentication. So now that that is there, I rerun my Phoenix server. Okay, and I go back to my user resource. Now. Yes, we can add the formatter configuration. So when we're adding extensions, because we're adding a bunch of DSL macros that we want to print without the ugly brackets on them, they all export a formatter configuration. So we just add that in there. Okay, and a little bit of extra work. So PHX for Rails Web. So Phoenix just deprecated route helpers as part of the 1.7, 1.17, whatever it is, the new version, and we still rely on them because I haven't fixed that yet, but that's fine. So we just re-enable that. The other thing is that in our application, we need to tell it about Ash Authentication, because we have some processes running. So Ash Authentication brings its own supervisor. It has some processes running to do things like token revocation and other periodic kind of things that we might need to do in our application. And we're missing a comma. Okay, so now we're ready to go to our user resource, and we can add our Ash Authentication extension. So we just go up here after data layer, which itself is an extension, and move those down to make them nicer. And why are we being told that this is wrong? Yeah, it's telling us that we've added the authentication extension, but there are no strategies defined. So let's get on with that. So now we've got our authentication extension. We need to, in Ash world, resources can be defined in multiple APIs, and multiple APIs can define resources. So it doesn't happen very often, but we need to tell it which API to use when accessing these resources. And we're going to say add a strategy. We're going to add password. We don't need a name because we'll just use the default. And we're going to say the really code completion identity field is email in our case, because that's what we've got, an email and a hashed password in our database. Some applications will use a username, some will use a phone number, that's fine. But again, we've got a compile error, and that is because it's telling us that email isn't uniquely constrained. We don't want to have two users with the same email address. That would be pretty confusing for our system. So what we need to do, sit down here, and we need to say, hey, Ash, we now need to generate a unique constraint for email. Now that's going to, because we're using Postgres, it's actually going to generate an index, so we can generate some migrations to do that. It looks at the state of the resource and the state it was in last time that you ran it. And I'm saying Ash Postgres generate migrations, and I'm giving it a nice handy name. And it's generating the migration for me. And we can open it up and we can say it's just doing your normal ecto migration. Let's create a unique index. And so now I can Ash Postgres migrate. Run the migration. Now our users are uniquely constrained by email address. So we'll run the server again. Yes, we don't. Yes, I know. Okay, so now we've got some more actions. We've got a sign in with password action, get by subject, which is used internally in token retrieval. And more interestingly, we have a register with password account, action. So you'll note that it has these fields, password and password confirmation, that are not attributes defined on the resource, but they're actually arguments that are passed to this action. And they're defined much the same way as you define an attribute, except on the action itself. So I'm setting this to test@example.com and test. So we're seeing the validations running in real time in Ash admin. Okay, I've created a user. There's their hash password. Cool. I can also sign in. So I can say test@example.com, test. And the fact that we get back a response means that that was a valid password. Whereas if I say wat, we get authentication failed. Some of you might have noticed that's a little bit slow. That's because it's running bcrypt in the background, and even when the password's wrong, it still runs it. Even if the user doesn't exist, it still runs it to make sure that you're not susceptible to timing attacks. So it should take the same amount of time whether the user exists or not, because believe it or not, people can actually just iterate over email addresses to figure out which ones you have by how long your API takes to, or your web page takes to return. So this is, I know I'm blasting through this, but this is kind of one of Ash's superpowers. And I think that's the most exciting thing, is the fact that the actions were created for this resource. And because they're a consistent description of what you can do with the resource, they can be reused. So I can reuse them in Ash admin, and I can use them in Ash GraphQL, can automatically generate a migration for registering a user and a sign-in query that takes the right arguments to make it work. Okay, so the next step is Phoenix. So we're going to go to the router. And we're going to say, hey, just add in some helpers, thanks. Just use this thingamabob. And down in here, after our home page, we're going to say we have a sign-in route. This is what shows the live view for signing in. And we have two other things. We have auth routes. So we say auth routes for the resource. We can authenticate multiple different resources with different strategies on the same application. So you might have users that sign in with passwords and admins who sign in with your, I don't know, your organization's Google credentials. And then we also have a sign out route because that's nice. People like to sign out sometimes. So if I save this, we're going to get legitimate complaints because we're referring to a thing called an auth controller that doesn't exist. So I'm going to go ahead and make it in controllers, new file, auth controller. Now, the cool thing about, the thing about the auth controller is that Ash Authentication handles the registration and sign-in of your users, but it doesn't know how you want to consume that user on the connection. So sometimes you might want to return, if it's an API, you might want to return a JSON result with a JWT in it, which you can do. In our case, what we're doing is we're saying, well, when there's a successful registration or authentication, or sign in rather. We're going to store that user in the session. We provide a helper to do that. We print some flash, and we redirect back wherever they came from. So, and if the person who sent us there stored where to go back to in the session, then we can pull it out and reuse it. Not that important. It's just a nice little improvement on your experience as a user. We also have a failure callback for what happens, what we should do and show when when their authentication or the registration fails. And then we have our sign out action, which is literally just a standard Phoenix controller action, but it's there so that all your code is in one place for what to do when the user asks to sign out. Now, in this case, we're saying, hey, clear the session, just erase it all, and then go back wherever, either to where you sent us or back to home. Next up, as of Phoenix, the latest Phoenix, we don't have views, but we have these HTML modules, and they're really the same thing. So that's fine. So I'm just going to make this and paste it in. This should be auth HTML. And then we need a template because our failure function says, hey, render this failure page. So I'm just going to do that, failure.html.hex. Paste it in. It's pretty basic. It's an H1 that says authentication error. Probably not what you want in production, but this is a demo. So now, with all of that done, we may have to restart the app, I'm not sure, but we should be able to just go straight to sign in. Yeah, and we do, but it looks funny. Why does it look funny? That's because of Tailwind. In Tailwind, we have to tell it scans through all your files looking for Tailwind classes to include in the bundles so that they're not too big. So in our case, we need to say, hey, you also need to look in the Ash Authentication Phoenix library for components that contain Tailwind classes. And as soon as we did that, you can see we now have this cool sign-in frame page. So we can also go need an account and register. We can go, hey, I've got an account, I'm going to sign in, and we have one that I made earlier. So this is test@example.com test. And we should have, let me guess, I bet it's the page size. Where's our flash message? Bugger. Do that again. Yeah, success, welcome back. And that was in our auth controller, you can say, yeah, we put this flash message saying, welcome back, and we redirected them back home. Now, if I was to fail to sign in, so let's say test@example.com, wat, we get an authentication failed error. And we see this single H1 that says, this is the default Phoenix layout now. It's pretty fancy. But that's cool. But what if I really thought wat was my password? So I kind of need to reset it. Well, that's kind of annoying. So let's go back to get rid of that. Go back to our user resource. And I'm going to say, well, actually, this is resettable. And we provide a sender function, which is basically a hook for you to send the link to or whatever to your user. In our case, we're just going to log it straight to the console because honestly, like, it's a demo. It's fine. It's complaining because expected. Oh, yeah, that's me. Okay, what's a 3-arity function? The other thing we need to do is that this generates a token. require logger. Cool. All right, this uses a token, but we haven't told it how to generate them. So we're going to add tokens enabled. Yes, but it's saying, wait. I expected you to set some things. The token resource option is not found. Now, as soon as you start dealing with tokens, you have the problem that you need to deal with revoking them. And sadly, that means you either have to keep track of every token, or you have to track the tokens that you have revoked until they expire. Now, by default, Ash Authentication does the latter, but you can change it via config to do the former. Regardless, we need a token resource, and that's used to store the token information in. So to do that, we need to create our resource. So we've given it a name. Now we need to give it a file. So we're going to say token. Now we're going to paste in the one I made earlier. And that's cool. And you'll note that we don't have to do very much at all except for say, here is an extension, and that extension takes care of defining everything we need for tokens, because 99% of the time you're just going to define this file as is and never touch it again, because it's kind of an implementation detail. The other interesting thing about this file is that I said, hey, store it in ets, because in production, I'd store it in Postgres because you want it to be across deploys and things like that. But in this case, again, it's a demo application. We don't have to generate any migrations. We don't have to do anything like that. So we can just start using it. It'll be stored in memory. Okay, the last thing is another implementation detail is whenever you make a new resource, you have to hook it up to the API via a thing called a registry. So I put it in here. And in our router, we want just like our sign-in route has a live view, we also want our reset route. Okay. Now I should be able to go to, I'm not sure if I have to restart the app. Forgot my password. That link wasn't there before. My email address is this. Ooh, what happened there? Well, that's a lot of backtrace. Missing JWT secret. It's right. Secret. Now, you shouldn't do this. You should configure it to use application configuration, and we do provide ways to do that. But for the purposes of demoing, let's not bother with that. Let's try that again. Forgot my password. Okay, so now I have this quite long token link. I can go in here, and now I'm going to set my password to wat. Oh, welcome back. That's weird. That's because of our auth controller. So we call the success function for anything that works, but in our case, we need to be slightly more specific because we need to say, hey, this is success for a password reset. And this activity is basically a tuple that says there's the name of the strategy and what it was trying to do. So we're saying, hey, when there's a password reset, don't log them in, that would be dumb, but just just give them a flash message saying the password's changed and redirect them back. So let's try that again. Forgot my password, this one. I'm gonna take this, copy. I'm gonna set it back to test, because why wouldn't I? Yep, success, password changed. So with, I mean, it's not a few lines of code, but with not many lines of code, we've generated an authentication system that is pretty configurable. There is a whole bunch of DSL options that we don't see that I've just left as defaults. So if I do, where's the, oh, it just says DSL entity, that's helpful. Okay, well, I'll drop some links later on. There's a whole bunch of options, like you can change the name of the, names of the actions, all that sort of stuff. You can also define your own actions, and we'll switch from trying to generate them to validating the ones you've got have got sane defaults. The other thing I wanted to briefly touch on is this sign-in UI. You probably don't want an Ash framework icon on your sign-in page, unless you're Ash. But these components are all, they've got a custom override system where you can change all the text and you can change the images and the CSS classes and things like that. So it's pretty good, but we do call it a starter API for a reason, because it's customizable but within limits. So there are some stuff we're still working on improving, but it's possible that you'll have to write your own forms, but at least you're not writing your whole authentication system, you're just writing a form, which if you can't write a form, then you probably shouldn't be trying to write an authentication system. We've got components in the ecosystem for dealing with forms in an Ash way for submitting them, that sort of thing, that work nicely with Phoenix. Yeah, so that's the end of the demo. Let's switch back to this, and can I do new share? Just Keynote. Yeah, look at that technology. Yeah, so the takeaways from this are, hey, you don't need to build it all yourself, and you don't need to maintain it all yourself. It's the open source way. You get the benefit of other folks also working on it. Save potentially months of effort. You get to focus on, on writing the code that your customer cares about, rather than the rubbish that they just thought would just happen. And it aims to be flexible enough for your application. So out of the box, we support auth, and we support a bunch of strategies, confirmation, that sort of thing. So hopefully, if there's a situation you encounter that we can't solve now, we'll add it to the roadmap and make sure that it's doable in the future. And worst case, you can always still write your own Elixir code to either make your own custom strategy or extend what we've done. Oh, and as always, security updates are only a dependency away.